Hello everyone. We are India Linux User Group Delhi, aka ILUG-D. We believe in introducing OSS and FOSS and Linux using development of the same. Today's session is on, as you all know, introduction on Golan, and today's speaker is Mohammed Falak, aka MFRW. This session will be recorded and it will be posted in future on our YouTube channel. Please do not unmute yourself in mid of this session. If you have any question regarding whatever MFRW said, then please put that in chat. And you can know more about our community on our website linuxdaily.org. The link is in the chat. You can also find our social links there. For example, the Telegram channel where we mostly talk about.
As well. In the meanwhile, okay. So let's get started. My name is Mohammed Falak, and I've been doing Go for a while now, and I'm really interested in the way Go works and the simplicity of the language. So this is a very light-hearted introduction to Go, and some of the idea where I'll try to sell Go in various ways so that you become more inclined towards it and probably choose to at least explore it once and see for yourself if it's something that you should actually go ahead and do. So before we do that, I just wanted to know if we can ask questions or make it interactive, or it's just going to be sort of a monologue thingy.
You can make it interactive, but please, people, do not unmute yourself because it messes up with Jitsy's automatic recording system.
Okay.
People can answer on the chat if that's fine.
Yeah. So a quick show of hands of how many of you are aware that Go is a language, or you're doing Go right now, or you've heard a buzz around Go or something. Let me open the chat up so that I can see. Folks can write in the chat if you want to. Otherwise, I'll assume this is. Yeah. Somebody says I've done a bit of Go, but I'm still not sure. Okay, Ravi. Nikhil has done a bit of Go. Ravi has heard about it. Interesting. Okay. Listening first time, want to start Go. Okay, Zion wants to start Go. Anyways, so let's try and see. I mean, what's the agenda about? It's a very light-hearted introduction to Go. I already know Python, so I mean, why should I switch? We'll talk about some cool stuff and who is the creator of Go? I mean, where does it come from? And then who uses it? Is somebody actually using it in production? And what's the all stuff around it? And I'm hearing a lot of folks say, yeah, I heard about it. It's famous. Danish says, Anime says played a little bit with Go. So, okay, let's first of all do a quick tribute to the demo gods. This is what a basic hello world program in Go looks like. There are a few important points to this. You have a package. Now, if you are from Python, it'd be a module. You have a package. Now, if you name it anything other than main, it becomes a library. If you name it main, it becomes a binary. Now, there are a lot of inventors have done which use very subtle things in the syntax, maybe nomenclature, maybe case of the letters, and they do something tricky with it. So you do package main, then you import something just like you would import in Python. So fmt would generally mean formatting, so import fumt. Okay, then again you have function, which is the main function, and you write something. You would notice there are no semicolons here, and then you write fumt, which you got from here, println, hello world, and looks like everybody is happy. Let's try and see if we run the program, what happens. So it says hello world. Now, there is a bunch of variations to this. I could even go, I could say fmt.print. Then if I just do print, I could do ABC. Now, the thing to note here is if I do fmt print fmt print efg, now I did not put an ln here. Let's try and see what will happen here if I go ahead and run it again. So yeah, I mean, everything seems to be fine. Things here, but again, so looks like this is how a normal Go function program looks like. Moving along. Now, there are some questions that we need to answer. I already know Python, so why should I choose a new language? And then we'd talk a little about cross-compiling is easy, and we'd also write complex code, make files, blah, blah, blah. And the tooling is awesome. Of course, I am missing an E here. So starting with the first bullet point, I already know Python. So why do I need to do a new language? If you look here, it looks mostly like Python. So why do I need to learn a new language if I already know a language? Now, one of the goals here is Go comes from the folks who made Unix and who made C. So there's a lot of bulk to who made Go. Primarily from language, you can go ahead and write, sort of add things to it. Everything happens in the open source, but it's primarily spearheaded by Google. And why did Google do this? They did a quick survey, and they figured out the average tenure of a Googler was around 3 years. And that's the highest. If you look at in the tech industry, Google has the highest retention rate, and the average turns out to be around about 3.5 years. I'm not really sure about the numbers here, so please don't quote me on that, but this is just the ballpark. So the average numbers are 3 years, and most of the code that Google writes is either Java or C++, and it is pretty complicated. And again, we might have seen that XKCD where it says, yeah, it's compiling, the code is compiling. So that was one of the pains. Also, they wanted a language. If you look at C++ or Java, looking at the intricacies of C++ and Java, the languages are extremely complicated. There is so much inside the language that you probably need multiple lifetimes to understand everything of every area. If you are good with, for example, the parallel programming in C++, you might not be very good with some other or template metaprogramming. You might not be very good with some other performance related stuff. So it's basically a very complicated language, and it also gives you a foot gun. Now, C++ is supposedly a language that is basically like you holding a foot gun. It's very difficult to do something wrong, but if you manage to do this, it's not going to just shoot you in the foot. It's going to blow your leg off. That's by Bjarne Strastrup, who invented C++. Like C++ is difficult. It's going to try very hard to not blow up on your head, alarm off, and you are not going to understand what will happen. So that's also one of those reasons. And then the second important thing, now we all have heard about the thing called cloud native. What is cloud native? Cloud native is when you want to do some programming and you want to deploy it on the cloud. Now, when you are looking at the cloud, you own a particular machine or a VM. You can have that VM for an ARM machine. Like the architecture could be ARM, the architecture could be x86, the architecture could be anything. The idea here is, or you could deploy on FreeBSD, you could deploy on Linux, you could deploy on Windows. Python, if you look, will build almost everywhere. You are able to run a Python program in Windows. The same Python program more or less runs on Windows, and it also runs on Linux as well. Assuming you have all the things, I mean, all the stars are right and everything is aligning, it's going to run simply. But the problem with a language like Python or Java is they are not languages that actually run on the metal. They run on a VM. Python is an interpreted language which runs on the Python interpreter. The Python interpreter has to be written targeting that architecture that you're writing to code. And then it would do fancy stuff like it would JIT the code, just in time compile the code and do other fancy stuff with the code. Or Java for that matter, you also run Java on a VM. It's not a like generic VirtualBox VM, but a Java JVM, Java Virtual Machine, that is sort of its own architecture. And when you go ahead and install it on a particular machine, you run the bytecode that you've compiled, and it goes ahead and interprets and does a whole bunch of things. Well, the Go folks said that we should aim at a compiler or a language that once you install, you should be able to cross compile almost with no effort on any target that you're running. So if you have Go installed and you write a small Go program, if you just do some knobs here and there, you switch the Go OS and the Go Arch. People lovably call them Gorch and Goose. If you put nice things there, you will be able to compile for any other target. You will be able to compile for Windows. You'll be able to compile for Linux and whatever the Go compiler right now supports. And you don't have to install any other extra tooling for that. If people might have done cross compilation in C, it's very painful, and it's very easy for you to get lots of host system stuff creeped into your binary. When I say that, for example, you are writing a small piece of code which you expect to run on a Raspberry Pi, but you won't compile it on Raspberry Pi. Why? Because Raspberry Pi is very slow, and if you compiled it there, then yeah, it'll take a while. So you go ahead and compile it on a faster x86 machine. But if you compile it normally on an x86 machine, it's going to build it for that x86 machine, so you won't be able to run it on that Raspberry Pi. So the thing that you'd have to do here is called as cross compiling. Although you are building on an x86 box, you don't want the output to be for the x86 box. You want it for the ARM box. So you install some extra compilers and some other stuff, and then you instruct the compiler that, dude, I am doing this cross compiling, and trust me, Nikhil here says it's a pain. It is extremely painful. Go kind of lets you go away with this. And let's quickly see a demo here. Let's see if we can go to a quick demo, and let's write a small program. Okay, I think I was doing some stuff here. So I'm going to new call of that. And I am quickly going to write a small main. I'm going to write hello world. And yeah, cool. I have a small Go program. If I do a Go build, it tells me, okay, Go demo is there. If I do a quick file of Go demo, it tells me, yeah, Go demo is something that has been built for a Mac system. And this is basically, if I go ahead and execute it, it should run here and say hello world. But if I say Go OS is equal to Linux and Go architecture is equal to AMD 64, and then I say Go build, interesting things will happen. You recall when we ran it first, we did. Now the reason why it's taking so much time is this is a Mac machine, and he will sort of do a lot of compilation and do some conditional things for which it has to build an which will run on an AMD 64 Linux platform. So if I let's see what happens. Okay, we have a Go demo thingy here. Let's do Go demo. Oh, now it says it's an L64 bit, and if I try to run it, it should break. Of course, it should break because Linux binaries are not supposed to run here. And even weirder is if I go Windows and I say Go ARCH is equal to i386, probably that should be it. Okay, go to test list. I myself forget this, so let me see. Okay, so we can compile on AIX, we can compile on a bunch of stuff. So let's see. Okay, we have here Windows, we have 386. So I think I had done this extra. If I go here and just ask it 386, he's going to do a bunch of stuff, and let's wait for it. Okay, file. Okay, now he says it's a PE32 executable, which is a portable executable, 32-bit. You can just lift it, dump it on the machine, and it will happily run there. this is one important thing. The other important thing with Go is it does static builds. We are going to come to that point as well. But since we were talking about why should I switch, and Go has become the de facto language for cloud native environments, and there are multiple reasons for that. One of the important reasons is why is it replacing Python so heavily is it feels like Python. That's one. The other thing is you do not have to have a Python interpreter on the target machine where you want to run the binary. That's the other one. And the third one is Go binaries are fat binaries. Now let's try and understand what a fat binary is. If I do an ls minus ltrh here, this is just a simple hello world. How much size is this? 1.7 meg. That's pretty huge. Let's actually see test.c. Let's go test.c. In C. Let's see what does that give us. Test. Oh my God, there's a huge difference if you look at it. This test binary, if you see this test binary, this also does hello world, and this Go demo. Okay, go build actually. And this main thing he also does hello world. But what's the difference here? This test guy is 48K. Go demo is 1.7 megs. Anybody would want to take a shot in the chat? Why is this crazy? I mean, this is insane. Why would you want to do this in the first place? Yeah, Chirag says it's Go runtime. Well, honestly, you're right, Chirag. But what Go does is Go always creates static binaries. Well, if you look at this test guy, I'm not sure if will LD. What is the alternative for LDD on Mac OS? I'm not really sure. Does anybody know? Anyways, I mean, what I wanted to show here is if you look at this test program would depend on the C library, which you need to have. You cannot just lift and shift this test program. Okay, O tool minus L. Thank you, Nikhil. Here, what does it say? O tool minus test depends on lib system something. And if I do an ls minus ltrh of user lib, okay, lib systm. Okay, for some reason it does, but again, granted that yeah, this guy is actually dependent upon this library, which we do need to have on that target machine. And if you take this Go demo thingy, this does not need anything. If you do an O tool minus L of Go, not Go demo, let me do main. It just tells you that there was no dependency at all. O tool minus L main. Again, it does tell you, but again, it's not there at all. Anyways, coming back to this. Well, most of us, when we take a programming language, that programming language does not come with a bunch of stuff. When you look at C, it just gives you a compiler, nothing else. Now, any self-respecting project is never made of a single file. So whenever you look at a project, you would either have make files, or maybe for recent projects, you would either have Bazel or CMake or Ninja or whatever the build system is. So if you want to play with a language that does not ship with something that lets you build stuff out of the box, you will have to do a decision, or you'll have to do some package management or some build tool decision of what I'm going to build this thingy with. So Go people knew about this because it came from Google. They knew about all of this pain and they said, yeah, let's ship with an opinionated build system. So if you look here, Go, if I just run this, it comes with a lot of stuff. So build is actually the build tool chain. that lets you build. And it's not only a single file, you can build packages, you can build binaries, libraries, all of this, and you just have to do very small stuff. Like you just probably have to do go build, and you have to give the output, and maybe this is some test, that's the output, or my lib or my bin, whatever you want to do there, and that's what is going to happen. Okay. Well, the other thing is when you look at languages, uh, very few of the languages come with built-in support for testing. Go people also knew this. They knew that people would love testing, and we should not think of testing as an afterthought that we'd have to have libraries. For example, in Java, we have Mockito and a bunch of other Java libraries that aid you in testing stuff. Because you have to, for example, you want to test a small function, you just cannot willy-nilly test that function. You have to build a full program around that function, a main function around that, and then pass some arguments to that. Then say, okay, 1 and 2. Okay, if the add assert that add argument A, argument B. If it is not 3, then yeah, break and do something bad. Well, Go ships with an awesome testing infrastructure that is inbuilt in the language. And the way you test it is you just write Go test. It slurps all the tests that you had written in files and lets you do a bunch of stuff with that. That people knew about other programming languages and the lack thereof was benchmarking. Like you want to write a small piece of code and you want to see how fast that piece of code goes. Go provides you a native framework for benchmarking the code and also a way to figure out where the hotspots are. If people are aware of flame graphs, if people are aware of tracing, Go basically was built around the gperf tools. If you have seen the gperf tools,
Here,
Go has
the experience
in
of face.
Girl's bathroom reaction. Should I pack my
I'm sorry, was there a question? Is my audio breaking? Okay, anyways, I will just ignore that. So it comes with all of those things pre-baked. You don't have to install anything else just to take a snapshot of what your code was doing. It gives you nice graphs of, okay, this is the hotspot, and here is where you can improve the code. And all of them are baked in the runtime. You don't have to install anything just for those. So if you've known the so if you know GitHub, pprof, this guy, this is what ships with Go. You just don't have to do anything. And it gives you an amazing view of what is happening inside the program. And again, the tooling for Go is awesome. How many of you would want to install something? For example, people would have done C++, people would have done Python. We have pip. And for pip, we do, for example, yeah, pip install XYZ. We have a requirements.txt file, and we have a bunch of other stuff. But then the problem with that is if you do not do virtual environments, it's very difficult for you to have multiple versions of the same library and they not having the probability of colliding with each other and causing a havoc. Well, the Go folks knew this, and they even gave sort of tooling to download and consume external dependencies. That too with almost not even writing anything. It just magically figures out that, okay, you want to consume a library X. Let's just download that library, and the version that you want to consume basically the Shaw sums of have I downloaded the right thing, or is there a malicious party who has done some stuff with that? And once everything is fine, I'll just link it together with all of my program and go ahead. So these are one of the things that made people switch to Go was the ease it gives you. Now we'll talk a little about who created it. Well, the creators of Unix. And there's a running joke. The legend has it that Rob Pike and Ken Thompson and probably a few of other folks were compiling some code in Google. And if you folks know, majority of the actual business code, which is the search engine in Google, is written in C++. And one of the greatest pain points of C++ is it takes a lot of time to compile. Now, that's a multi-hour compile, and they're brainstorming there, saying like, okay, in 2000s, we are in the millennium, and we're still waiting for compilation and waiting for a language that was developed in 1980s to compile. There's no ergonomics to the language, and they thought about trying to solve this problem. Okay, one of the problems that C++ has is if you look at the header files, all the header files, wherever you have them, like hash include, whatever, header files can include some other header files as well. Now, the problem is at the end of the day, you just see the header file only once. The problem is if you have 5 different lines or 5 different files that include stdio.h, or some include file stdio.h will be read 5 times from the disk. Then eventually the compiler, the preprocessor, and all of those other folks are going to say that, yeah, sure, we've read this one, so probably we don't need this. But it will go and read that a bunch of times. So they said, okay, one of the easiest ways to stop that happening is let's create a rule. We will sort our imports. Well, import is just like including something. We'll sort our imports so that then we can go through all our files since we have them sorted, and we can create the diff, or we can find out what is common and read those files only once. That saves a lot of time. So Ken and Rob were waiting for a project to compile, and they thought of redesigning a language. And that's how, I mean, I think Ken Thompson probably rolls. Well, he goes one day and says, yeah, we don't have grep. If you folks know, grep grep is probably Ken Thompson in one night. So there was this editor called EX or ED, if you would know. I mean, ED is the line editor, which is the father of VI. So ED had a feature called as visual, which got shortcut to VI. People used to open ED and then so then they actually renamed ED to VI. So that's one of the reasons why the weird name VI or Vim, if people might not know. So yeah, so these folks say that, yeah, let's design a language. Now, one of the prime goals for this language was like I talked earlier. Google had done this research that most of the tenure for people is close to 3 years, maybe even less. What should we do? When a noogler comes in, he takes round about a year and a half to bootstrap, given the complexity of the code, because the code is extremely complicated. It takes him a year to learn and do meaningful contributions. And that is just 1.5 years in which he has to contribute and then he leaves. So actually what we are getting out of a new folk, if somebody joins Google, is just 1.5 year. For the other 1.5 year, he just learns himself, because the scale at Google and the complexity at Google is so much that it takes him a while. So they said, okay, one of the design goals is that this language should be easy. If somebody knows basics of programming, he should be able to come in and know what's happening in the code very, very quickly. Of course, it will have its intricacies, gotchas, but at least if they want to understand, they would be very quick to gain it. So there is a question from Chirag: is Golang written in Go itself? Yes, Golang as of now is written in Go, but of course you cannot write a language in the language itself. So it's basically a recursive problem of how did the first compiler begin then. So till Go 1.6 or 1.4, till Go 1.4, Go was written in C, and they used to first bootstrap. Go 1.4 was the the base compiler was written in C. They used to compile some very rudimentary parts of that and get some working compiler, and then the rest of the compiler was written in Go, which they use that C compiler to bootstrap the compile process and finally generate the compiler in Go. And as of now, the whole compiler is written in C. So Go is like 1.17 right now, and the whole compiler is written in Go. So if you want to build a language, if you want to go ahead and build the language at your own sort of machine by downloading the sources, you would have to download a bootstrap compiler, which is a binary because you cannot do it even if you have C, C++, because none of it, there's no C code in Go. So coming back to the design point of it. So since Ken Thompson is one of the guys with Dennis M. Ritchie, DMR, who created C. So these are the folks who did C. So I mean, I think DMR would be a part of it if he was alive, probably, but since he's not, so this is what we have. We have Ken Thompson, we have Rob Pike, and we have Russ Cox. So Ken Thompson is Unix, he's UTF-8 and probably the god of computing. So yeah, that's there. Rob Pike is a lot of languages, Newsquake, and a lot of work in the Unix system, and both of them are in Google. And Russ Cox is also some compiler nerd who also joins them. So they say that, okay, we'll only have 25 keywords, and the language should be extremely simple. Now here, there's one more thing. People call this thing as Go, or they sometimes call it as Golang. Now the reason it is called as Golang is if you search for Go, the answer would show up as the game Go, if people are aware. The game Go is a very simple game, and the idea is there are very simple rules in Go. There are two kinds of stones. There's black and white, and there's a board on which there are some boxes. Black goes first, white goes second. And if you all recall, in our childhood, we used to play that dot game in which whoever closes the box wins that territory. A similar thing happens with Go, the game Go as well. It's very simple to understand. There are not many rules to it, and you can start playing it probably in 5-10 minutes. But to master Go takes a while. So this is also one of the reasons why this was called Go. I'm not really sure, but people do say that this may be one of the reasons why they said that let's name it Go. It should be extremely easy to pick up. But yeah, I mean, mastering it takes a while. For example, we conquered chess in 90s. In 1990s, we did conquer chess, like Deep Blue beat Garry Kasparov. But to conquer Go, it's such a simple language that the search space is just crazy. It's so huge that it was intractable for a sequential scan of the whole search space and beat humans. So if you all recall, like 2010-ish was the time when AlphaGo beat Lee Sedol, who is a Dan 10. Dan 10 in Go means the Grandmaster. So like chess has grandmaster, national master, blah blah blah, and the top is grandmaster. Similar stuff happens for Go, where the top guy is Dan 10, Dan 10. So he, the AlphaGo thingy, beat Dan 10 guy. So it's very difficult, and it was very complicated for machines to conquer that. So this is also one of the reasons why people called it Go, because it should be very simple to pick up, but then when you have to master it, it should take a while because there are a bunch of intricacies. Again, there are 25 keywords, and since it comes from C, most of the keywords are already seen. People know most of the keywords. The only thing with this language is probably 3 or 4 keywords that people might not have seen. That was one. The other design choice that these folks had is they wanted a language which was easy. So now comes the trade-off. C, C++ is a very powerful language. It lets you extract the last amount of juice from the processor, but then there's a lot of peril involved there. If you allocate a piece of memory, You, which is the programmer, has the responsibility of giving it back. Of course, there are destructors and all of those. So even if I disregard C++ here and go to C, well, yeah, you are completely on your own. You take some memory, you malloc some stuff from the operating system. It's you who is responsible to give it back. And that is cognitive load on the programmer. And it's a problem for a lot of concurrency bugs or some memory safety bugs. Okay, so they said let's do one thing. Let's give a garbage collected language. Okay, that was one design, that this is going to be a garbage collected language. So you do not have to do anything. You just have to allocate memory. The Go garbage collector is going to take care of the rest. And one interesting note here is that there's this guy called Richard Hudson who has worked on his entire life on garbage collectors. He used to work at IBM, and he in some time switched to the garbage collector of Go. The best thing about the garbage collector of Go is it's the fastest garbage collector on any language. I mean, please don't quote me on this, but as long as I've seen, and I think there are claims that say that it is the fastest garbage collector. But again, I mean, I do not have any sources, so please don't quote me on that. So that was there. And the other thing was, every language that we have seen so far was on the paradigm of 80s. Like, yeah, we are going to have a single processor, and that's going to go faster. And we are going to increase the frequency of the processor, and we are going to increase the cache and basically the beef. We're going to throw more money at the problem. So our code is going to become faster. Well, unfortunately, 2010, 29-ish, the free lunch was over. There is no more increasing of the clock frequency. So these folks already knew that we cannot sort of throw money at the problem by buying a faster clock CPU. So they did what probably none of the languages, none of the major compiled languages that we majority work with have done. They built concurrency not as a library, but as a language primitive. So now when folks say, for example, there might be a question that, okay, what does that mean? So for example, let me talk about C. C also does multiprocessing, I mean, multi-threading, but then you'd have to use the pthread API, which is a library, the pthread library. You have to do lpthread if folks are aware. There's nothing inside C that tells you that, yeah, this program is multi-threaded, this program is not. It gives you the primitives. Every program basically is its own thread. If you want to do two threads, go ahead and create one more and make them talk to each other. So that's the C model. Well, what Go said is, Go said that, yeah, we are going to provide an language primitive which is going to do this multi-threading, and it's going to do it in a very interesting way. It's not going to do actually threading. It stems from something called communicating sequential processes. Now, Go happens to be one of the languages where two paradigms meet. So if you look at primarily the languages that were developed in European areas, most of them have a functional feel to it. And if you look at the languages that have been developed in the Western sort of USA, that sort of region, most of them have the procedural sort of a feel to it. Well, in Go, people from both the factions came together, went on a whiteboard, and then said, okay, what are the features that we do not want to have in the language? What are the features we want to have in the language? And they voted for each of the factors. So it has a flavor from functional languages as well. Though it's not a completely functional language, it has a flavor from procedural oriented, object oriented, those kind of things as well. So it basically culminates a lot of research. So if you've heard of Nicholas Wirth, so one of the inventors in Go was a PhD student of Nicholas Wirth. So that's where some of that comes from. And then Ken Thompson, Rob Pike, and all of those heavyweights were on the object oriented, that sort of front. So it has sort of all of that. So a question could be, is Go object oriented? No, it's not. It looks and feels like one, but it's not. There's this thing called composition, what you could do with Go, but unfortunately, no, it's not. It's not a language that is an object oriented language. Is it a functional language on the other hand? No, it's not. It feels functional, but it's not. And one more important point that I like to call out here is, if people might have heard, there was a paper, a seminal paper by a research scientist called Tony Hoare, which is communicating sequential processes, which is the basis of Erlang. Like Erlang is built upon CSP, communicating sequential processes. Make small processes and then talk to each other. Do not lock memory. Communicate by messaging. Do not communicate by putting a lock on a shared piece of memory and then ask everybody to contend for it. But no, flow, messages flow, send messages to each other so that you could do stuff. So Go has that idea as well. And one more idea about Go is the threading model, which is, although if you look at normal, for example, C, C++ type language, or Java for that matter, on a decent machine, you'd be able to probably, for example, I mean, I don't know what the definition of decent is, but taking my machine, for example, I have a very old MacBook Air, and let's try and see, what do I have? Yeah, I have like 4 cores in my MacBook Air. It's a very tiny machine, and on this sort of a machine, I can expect somewhere around, give or take, 2,000 threads for a single program. If I do 2,000 threads, I think at that point in time it'll start gasping for air. I mean, I'll feel it. If I move the mouse, I'll see the mouse stuttering. I'll see bad stuff happening with the machine, and the fans going all crazy and stuff, because those 2,000 threads are actually threads, and the operating system has to do a lot of bookkeeping and then schedule each one of them. And if all of them, those 2,000 threads, are long running threads, yeah, God be with my machine. Okay, Chirag asks a question. I might have read in documentation that it is object oriented, but doesn't have classes. So you use structs for objects. Doesn't that make it object oriented? Then maybe I am not really sure what is the on paper, like, solid definition of object oriented. But from the people I've heard, and I've tried to hear some of the things from Rob Pike as well, and Russ Cox. Please don't quote me on that, because I mean, it's been way back. So this things that I'm talking about, I've heard in probably 2016ish, 2015ish. So I'm not entirely sure who did I hear, but I hear one of those folks saying that it is not object oriented. But there's no, I mean, if you want to call it object oriented, go ahead, call it. I mean, there's no such, like, uh, paradigm Nazi here, that yeah, this is basically an object oriented language because it qualifies these 4 definitions. But the thing to take away from here is, it has a composition model, while as object oriented have the inheritance funda. Here you cannot inherit. Now if you actually, if I rephrase my stuff, is that Go does not have inheritance, it has composition. Now you make of it, probably you want to call it an object oriented language or not. That's probably left for your discretion. I hope that answers the question. Anyways, so where was I? Yeah, they thought of making the language. They said threading model. So in Go, we were talking about the number of threads. So we said that yeah, we'd be able to spawn like 2,000 threads, and the machine is going to gasp for air. But in Go, there's this term called green threads, which are not actually threads. They are threads in user space. So the Go runtime, since we have a garbage collected language, we definitely have to ship a runtime. So the Go language itself has a scheduler, and it has an implementation of very cheap threads. Like, they grow with the 2K stack only. They have a stack of 2K, and then they do fancy stuff with it. They grow it if it needs, but to begin with, you can have a Go routine. That's what they're called. They're not threads. They're called Go routines, which runs parallelly. It's a separate thread of execution, and it's very cheap. You can probably spawn 1 million of them on my machine. and this machine is not going to stutter even. It's going to run all of them. Of course, not all parallelly because I do not have 1 million cores, but however many cores I have, it'll schedule all of them nicely on each of the cores and it'll take care of them nicely. So this is also something that is one of the prime things that people look at. So if you want to do something very quick and dirty, but also leverage all of the performance of multi-core CPUs, you would probably want to go and take a look at Go. You would say, yeah, Python would do the same. There are a couple of problems with Python. One, it's an interpreted language, so the speed is not going to be that much. I'm not against Python. I write Python a lot, so I love Python, by the way. So there's no riot thingy here. But I mean, I'm just talking about a trade-off. So if you go and have Python, yeah, Python, we have that global interpreter lock. Of course, people are working very hard on it, but still, like there is the global interpreter lock that will not let you use all of the processors nicely. Well, Go has everything built in for concurrent concurrent processing, and what you would do is you'd spawn a bunch of Go routines. They all will go and schedule themselves on multiple processors, and the runtime is going to take care of it. So yeah, you'd get much better performance, and you are writing almost similar code or sometimes even less of equivalent to Python. Now you'd say, of course, if I want performance, then why would I not choose some other language? Why would I not choose C++? Well, yeah, writing a web server in C++ and then doing some bunch of stuff with that is going to be a little challenging. I mean, if you want to do that, of course you can. People have done that, but like, why does one go for Python and not C++? If we know C++ is fast, just because it's painful. It's outright painful, and the reason why certain decision is made that I'm going to go with C++ is because I really care about performance. And that's why I would need to go and do that performance specific code. I want to beat my head with a wall and do the Python thingy, not do the Python thingy and do the C++ thingy. Well, Go is a trade-off here. Go says, I'm not going to be as fast as C++. I'm going to be in the ballpark, but think about it. The code that you're writing is equivalent to Python. So if you wanted to write 10 lines of code, you still have to write 10 lines of code, but it's going to be much, much, much faster than Python. Of course, not C++, but equivalent to C++. So that's one of the reasons why one should take a decision of look there. And then again, we talked about those other structures. Moving around. What's the structure of a typical Go program? Again, we talked about it a little, but again, we'll see. So every Go program has this package preamble, which says that, okay, what is this? What's the name of the package? If we talked about it, if it's main, then it's a binary. The whole program is a binary, and you can have multiple files. Some imports, some global variables, and Go calls functions as funcs. And one more interesting thing about Go with respect to C is if you see a small C program, let's do, yes, anime says there's a lot of differences. There are a lot of similarities. Yes, there are. So if you see a small C program, a C program, int comes first and then comes the function name. I mean, whatever it returns comes first, then the name of the function. argc is an integer. Char star argv is a double pointer to a character. I mean, it's a character array for that matter. And then you do a bunch of stuff, and yeah, there's a semicolon here. Okay, let's look at the typical Go program. Let's see, how does that look? If you of weirdness here, that is, this func comes first. So let me actually write fib.go. Let me write a small Fibonacci function. Yeah, well, this is some weird stuff. Okay, wait. Let me go ahead and do fib.go here. Okay. I take an int, I return an int. Okay, if n, okay, I don't need the semicolons. If n is less than 2, what do I do? Return n. Otherwise, return fib of n minus 1 plus fib of n minus 2. Okay, that sounds Okay, of course he's not happy because he's telling me fib is redeclared in this block. Do I have a fib anywhere else? Not sure why is he doing this. FMT print f, because it can do print f as well. Fib of 10 is equal to %d backslash n, and I'm going to call fib of 10 here. Let me go ahead and do this. I don't know why is he not happy, but I am going to nuke this test.c file as just test because probably there's a reason rm go demo. What's wrong? Yes, so I wanted to do some testing later on. That's why I had this. Okay, let's do a quick open. Okay, it basically, now let me take a look at this. If you look at it, it looks inverted. The type comes first, the type comes second, and the variable comes first. So yeah, this is otherwise it's all the same. It's basically C with a bunch of stuff added, a little bunch of stuff added to it, a couple of keywords added to it, and you don't have to write the semicolons because the compiler will place them. But if you are really like you want to add them, you can add them. Again, the Go formatter is going to get it back that yeah, you don't need it. It's going to add it itself. But for example, if you still want to see like a invocation of a semi, yeah. So here you need semicolons because that's the only way to differentiate between these three statements. Like this is the initialization statement, the statement which tells you, okay, I'm going to run this piece of code till 10 times, and I'm going to say loops. Yeah, let me quickly go ahead and run this, see what happens. Yeah, it says loops, 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 blah, blah, blah. Okay, cool. Anyways, and you have this func main. I would want to go a little bit of detail, but I think we are close to 10, and it was just an introduction, so I'm not going to bore you with this. I'll probably take some time to go through the rest of the slides because that's not going to be that heavy. So is it Go object oriented? Now this is the answer. Although you can use it as an object oriented language, it probably, let's put it as, is probably is not. It does not have inheritance, and then it depends on your definition of do you call an object oriented language if it has an inheritance or not. It feels like it completely feels like one. So yeah, maybe. Okay, let me try to sell Go. I have already tried to do this. Cross compiling, we did see what pretty loaded standard library. Oh, mean? Well, a pretty loaded standard library means it has lots of stuff inbuilt. You can start a TLS server in less than 3 lines of code. And you can start a web server in probably a couple of lines of code. And let me actually see if I can write a small web server that does hello world. Let's see, how difficult would that be? So if I do http.handle func, let's say I'll call it test. This guy is going to be called on this, and then I fatal http listen and serve. Now this is the thing that you need to do to spawn a web server, this line, and that's it. Of course, yeah, he's going to yell at me for a bunch of things that I don't have test, I don't have blah, blah, blah. So let me quickly write that. So people write these handlers a lot. So yeah, there's basically a lot of shortcuts to get these guys up. Let me name it as test. Oh yeah, I have messed up here. So this comes first and test comes second. I'll try to explain this, but again, saying is start off an HTTP server, which is the default one, and attach to the default one function test, which gets hit when somebody goes and hits my root. Okay, simple. And what do I do on that? Whenever somebody hits my root, go and send this to him. What do I need to send? From Go web server. Okay, now I'm going to talk a bunch about this because this is a very interesting piece of code. Now, if you guys, like if you folks look, we wrote 2 lines here, and then we wrote some business logic here, which is just a single line. And let's try and compile it. Now, again, we are compiling this. And he says, yeah, do you want the application to do something? Of course I do. Let's see what I'm listening on. He says, okay, he didn't say anything, so let me kill it. Let me go ahead and print. So I even have log.println. That's going to do like nice thing. Starting web server. Okay, let's not say web. It's not HTTP. Starting a server. Of course it is. Web server on 8080. Okay, that looks fine. Now let me start it again. Yeah, I'm sure I want to run this. It's just me. Okay, I'm starting a web server on 8080. Okay, fine. So if I do a wget, I don't have wget, I have curl localhost 8080 slash. Oh, he is saying go from web server. It's interesting. I was able to do this. Now, some of the interesting things about this design is this is a production ready web server that's going to rival Apache. Probably beat it, and it's going to be almost equivalent to Nginx. If you don't see, if it's just your web servicing of static files, this is what you would need. And this is an implementation that was the production implementation for a bunch of services I used in my previous organizations and the current organizations as well. Well, let's not name those organizations, but just a small hint, they were, I mean, nanoseconds matter there, and the load that we are talking about is not like world. We're talking about stock exchanges and people hitting you very badly. And yeah, here was a little business logic. That's it. I mean, this was the production level code. So, and again, the best part about this is it is not single threaded. If you go and blast it with things, this listen and serve guy is automatically going to create separate threads. Now, of course, let's talk completely normal and technical here, not threads, go routines, which will be whatever you write in here. Think of it, you writing an extremely complicated internals Nginx thingy, and the runtime just making sure that it feels like you're writing parallel code. I mean, you feel like you're writing serial code, but that code is extremely parallel, and the runtime just takes care of everything of it, multiplexing, saving the state, getting somebody else, running that guy. Okay. Anyways, there's this joke. Chirag says he didn't say anything. Oh, okay, okay, yeah. These guys are saying this is what I said. Okay, so one of the important things about Go is the writing thingy, the tabs versus spaces. I believe that's the question. I think the tabs versus spaces and all of that. Is that Nikhil you're trying to ask? Oh no, not that. I will take that probably offline because I am not able to understand. So one of the things about Go is there are no opinions here. the code is formatted by a machine, and it also comes compiler. So even if I try to indent the code, and you see, I'm doing a write. If people familiar with Vim should understand that I'm trying to save it. Well, the moment I save it, this guy tells me no, nah, 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 nah. I'm not going to let you do this. This has to be indented with a tab. And whatever I do, even if I go kill the tab, add spaces. So you see these markers, like these are space markers for me that tell me that, okay, yeah, this is almost a tab now. So if I save it again, this guy is going to tell me, no, that's not going to work. I know what machine written code and human written code. So yeah, there's no distinction. And there's this one way that I'd let you do this. And the guy who wrote this, he was asked, what's your best thing? What's your favorite thing about Go? He said the Go formatter. And what's your worst? What's the thing that you hate about Go? He said the Go formatter. So yeah. Okay, you mean the relative imports through while we're working? Yeah, you can do this, but then there's this amazing thing called go.mod, which lets you do really intricate stuff. I don't think I'll have the time or probably the sort of the base. This is a very beginner track, so I'm not sure if but of course, please do reach out and I'll be really happy to talk about it. Again, all-round development like benchmarking, testing, all the profiling and all that stuff is included. Relatively leaner build times. Now, generally, I can actually do this. And I know that this is going to work just because I am sure about. So what I'm going to do is I'm going to pull the latest source code for Go and I'm going to make it and I'm going to time it. So I probably will not even attempt to do this with C, C++ is a multi-hour effort on a very, very heavy machine. It's almost like we take it as a test for one of our machines of how good our operating system and all of the integration is. We go and compile GCC there. Just like, हाँ ठीक है इसको GCC compile. I'm sorry, I'm talking in Hindi. People who don't understand. I just want to say that what we say, like, इसको GCC compile करने को देते हैं और देखते हैं क्या होता है. Which means let's give GCC to it and see what happens with it. How good this is. So it's basically a pain that we give that machine and let that machine go through the wrath of compiling GCC. I should be done on a 2016 MacBook Air that is probably should not compile anything as of now, 2021. But yeah, I'm able to compile whole of the Go toolchain, all of the language here in less than 4 minutes. And generally, that's going to be the case. All of the projects that you look at are generally going to be of the order of 5 to 7 minutes. It does not matter how big the project is. Of course, like you would say, Kubernetes takes too much. Well, there's Bazel doing a lot of stuff for you, but generally, like the things that you do and then when you try to build them, it generally takes a lot less amount of time. And of course, extensive tooling. It gives you testing, fixing, formatting, everything. You don't have to install a single thing. Everything comes in, like downloading, vendoring, and all of that. Let's not. Of course, yeah. Looks and feels like Python. It's statically typed. You cannot say that this variable is an int and suddenly change your mind and say that this variable is a string. I am not attacking any particular language. All of them have their own sort of reasons to do things that the bugs that you would do are caught generally on compile time. It's a compiled language, and this is just like a trivia to it. So this is only one of those languages that compiled languages that lets you mult-ret. So let's say I don't do anything, and what do? I can return a string and a string. This is probably I mean, of course, Python does, but Python is not a compiled language. If you look very carefully, there's going to be very rare of a situation where there's a compiled language and that lets you do multiple return values. Of course, people would say Rust, but then if you look, Rust does option or it does result. So of course, that also doesn't give you it returns a struct that has two things or something like that. So it also does similar trickery here, but then again, just a quick sort of trivia. If people know about a language, please let me know because I am not really aware. Anyways, it's simple. Again, that I would like to go here, go by example.com. Let's go there quickly. Come on. So these are a bunch of small programs. If you look, they start with hello world. They tell you what to do, like write this small program, go run hello world. You can even make it look like Python where it just runs it without compilation, but then you can also go and build it. So here the trick is that it compiles it in temporary and then builds it, then runs that part of it. It doesn't do interpretation. But again, like, yeah, you can do that. And there's a bunch of other things. And these start like very simple and then go difficult. And if you probably spend like probably a couple of days here, given that you know some programming language, you should be up and running with Go in no time. And because all the things that are there, I mean, there are only how many? 25 keywords. Well, there are 42 programs. I'm not sure. Last time I checked, there were 42 or 43. I don't know how many are there now. But if you go through them, there are going to be a couple of things that are going to be a little challenging: interfaces, channels. I think rest of it should be, I mean, of course, as you move down, you would be more aware of what I'm doing. I mean, I know what I'm doing stuff like when you go downstairs, but then this is something that should be sort of, Go takes a different approach to interfaces. You don't have to implement an interface, but again, I don't want to talk about that. And channels, this is the communicating sequential processes thingy that you can create some channel here. You can say that, okay, make a channel of strings. The channel is messages. Then you can go ahead and dump in that channel ping. And this is weird where, let me talk about it. So he creates a lambda. Let's forget this go here and forget this brace here. So func is basically a function, an unnamed function. Create a lambda that encapsulates this message and then write ping to it. And then writing go in front of any function means run that parallelly. So this is built in the language. Go means just run that parallelly. So what happens here is this code runs here in a single thread. Messages, he is still single threaded. Here he makes one more thread where he runs this messages and dumps ping on this messages. Here on the initial thread, you grab that messages in the message variable. Like this is the way you send it to a channel, and the brace here, this is the way you receive from a channel, and you go ahead and print that out. And generally, sometimes it just may so happen that if you run it enough times, this ping should not even get printed, but that is for advanced. So I'm not going to talk about that. Okay, correction. It's not really a systems language, but yeah, is this yielding from a function? Yeah, typically, but then yielding is still having that same thread and giving that thread to somebody else. This do use it a lot for web dev, but generally they use it for distributed system stuff. And what they want to do it is, since the TCP library that comes inbuilt with Go and the crypto library that comes in with Go is not the fastest, but it's just completely batteries included. It can do HTTP, it can do HTTPS, it can do WebSockets, you name it, whatever is modern, it can do that. So it becomes extremely easy. Like we saw, we were able to spin up a web server, a production grade web server, in a short amount of time. And let's actually do some. And let's say I want to do 10,000 requests on this, and I want to concurrently hit it I want to have a concurrent. How many cores do I have? 4 cores. Let me do 10. So what I'm doing is I'm calling Apache Bench, doing a total of 10,000 requests on this program, and I am doing it concurrently in batches of 10. Let's see. Oh, he's not happy. Why? Test about it after 10 failures. Am I even running this? Let's see. What the hell? Not really sure what happens. Let me nuke this. Starting a web server. Okay, I know I'm starting a web server. Go just to make sure that nothing bad is happening. Oh yeah, I had not done this allow. That's why he didn't let me do this. Let me go ahead and call this. So he's doing all these requests and he's going to print a nice summary. Okay, what did he do? How many requests? 10,000 requests. And this is the connect, like this is the tail latency, 155% of milliseconds, like 155 milliseconds, like the largest, and 50 percentile, whatever. There were some numbers, and the transfer rate was 89.94 kilobytes per second. Let me quickly do something. Of course, I should not do this, but then again, Python -n http dot server, and I just am just for the fun of it. Of course, this is not an apples to apples comparison. I'm comparing like a simple HTTP, which is bad. I should not do this comparison. But then I'm a person of science, so let me do this just for science. So let me go up and let me run the same command. I'm not going to do any change here, and I'm removing all these traces here. So we will scroll up and see later what happens. So I'm going to run here, and the moment I send this kind of a load to the Python program, that program just gave up. He said, dude, I probably will not be able to handle this kind of load. So he just blew up. So I'll ask it. So I don't want concurrently 10. I'll just take concurrently 1. Let's see what happens here. Yeah, he's able to do concurrently, but then again, I'm doing like 10,000, so probably that is bad. So see, he's completing 1, 2. Are you seeing now? If I kill this Apache Bench, I go here, I kill this program, and I call go demo again. Okay, he's starting something, and I'm going to run the same program here, see what happens. Are you here? Well, let's see what is our CPU doing in the meanwhile. Of course, he must be very angry with me, but then we're using all the cores. I didn't write a single code or single thing here to do complex multi-threading and then pin things to cores. But yeah, I mean, the Go runtime is good enough and nice enough to do that for me. Anyways, again, let's go back. Docker has been written in Go, Kubernetes has been written in Go, and a bunch of tools that you use like GitHub CLI, a bunch. Go has been written in Go. So there's actually a lot of things that people do use right now, which are written in Go, and there's a reason. If you want to have a binary that you just lift and shift and drop it on a from scratch container, that should run. Well, that's not going to happen with a Python thingy or a C++ thingy unless you statically build it, which is going to be a challenge of its own. So Go just by default gives you a static binary. Just go lift and shift that binary, dump it on a cloud native container, like from scratch, dump it there. You'll be happy. And like let's actually see something really crazy. So I know this Go demo thingy is a web server that is written in do a bunch of things. Now, if I go and do this environment Windows, Go Arch, and blah, 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 and go build it, what do you think will happen? Well, folks, what I'm going to do is I'm going to put a -v sign to it so that it tells me what it's doing. So it tells me, yeah, he's compiling a bunch of things, and he's going to create a binary that will run exactly the same way as it ran here on a Windows machine. That means you are able to create a complete binary, not an interpreted Python thing, a complete binary that is going to contain entire core or entire resources of your Windows machine. And yeah, this is the piece of code that you'd have to write to do that. And I use it. I don't think I would have that. So I will see git clone https github.com mfrw file server. This is not nothing. Oh my god, github.com file. Did I? It's yeah, this. Oh yeah, I already have a file server here. I'm sorry. Yeah. So this is something that I use, and I just use it for everything. And the reason why I've written it in Go is tomorrow if I want to go a very constrained box that doesn't have Python, I know that I can very quickly build this file server for whatever platform I want. For example, Go, Tool, Dist, List. I want to build it for ARM and dump it on my OpenWRT router. To write. Of course, that's going to be a little big, but again, env go tool dist list, and let's just grep for ARM. So I can do Linux ARM64. So env Go OS is Linux, Go architecture is ARM64, and I want to build it. So this guy is going to create a small file. Let's see how much big of that file is. Meanwhile, it compiles. Let's move. Okay, yeah, let's start coding. So we are mostly done. Like, so folks, please let me know if I'm taking too much time. If it's okay for me to take how much, 5 or 10 more minutes? If it's getting too overwhelming, too boring, or if I'm boring you folks, then do let me know. I can try make it more fun. Anyways, this guy is back. Chirag is saying smiley. That means probably he's happy. Anyways, this is a 5.7 meg file that is just lift and shift and drop it. As long as that guy is a Linux binary care, even if it has glibc there or not, because I just don't need it. I have everything here to run. So yeah, this is very cool. Anyways, moving right along. How do you do variables? There are, unfortunately, the thing where they said that, yeah, we should be simple and just have one way of doing things. They've just done one mistake, which they really regret, is you can create variables like this. It will automatically interpolate that, yeah, F should be a string. But apart from that, if you want to create a variable, you say a variable, and then you say the type of the variable, and then you say what is it. It can even do interpolation where you don't have to write a bool here, var d, you don't have to write bool, it'll just figure out it's true. This you can only do inside functions. You will not be able to do it outside the global scope. There you have to specifically write var a string global blah 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 initial. You don't have to write global, but let's try and see. So what I'm doing is go, and I'm adding concatenating strings here. Okay. Anyways, Nikhil says it was so confusing for me. Of course, yeah. But this is just a short way of declaring and allocating that variable, like assigning that variable. Anyways, go plus lang, it should print something. So let's go ahead and run this and see what it prints. And then let's try to make something out of it. So if I do one more thing here, will it work? A space is fun. So let's see if I run this program, what will happen? Yeah, it says Golang is fun. Anyways, Formed 1 plus 1 like normal binary. I'm just arithmetic. What is true and false? Of course, it's false. I know. What's a string? Print string. Okay, initial or B, C int 1, 2. You can do multiple initializations as well. B and C is 1 and 2. Okay, D is int, haven't initialized it. So everything, if it's not initialized, it will get a zero value. A zero value is what would make sense. What would a zero value for int be? Of course, zero. So that's why zero. What would a zero value for a string be? Null, nothing, no string. So that would be there. So this is a declaration. You're doing something. You can have consts as well. And again, it just figures out. You could also write an int here or something else here. But again, yeah. So yep. So this is variables, blah, blah, blah. Let's see, loops. How does loops look? There's just one loop. There's just for loop. There's until blah, blah, there's no. And depending upon the arguments you give to that loop, so for example, for I less than 3, there is no initialization, there is no addition condition, there's just this middle condition. So what will this be is this is just a while I less than 3 sort of loop. I mean, this sort of translates to while I less than 3. What is this? This is the generic for loop. You don't have to have those braces around, like that bracket around like you have in C. Why am I calling C so much? Because it's a language that's derived from there. All the ideas have been taken and a little bit of modernity has been gotten into it. And then this is just a complete while loop, a while true loop. This will never break. Let's try and run this and see how it works. Okay. Okay. How conditions work? Like you don't need a brace around the condition, but there is no leaving this brace. Like C used to do, for example, if you just have one if condition, like one condition inside an if, you could omit the brace. This guy does not like it. This guy will let you have that brace even if it's a single one. And generally, if you don't have any else condition, just omit it. And yeah, you can allocate a number, then and this num is going to be active. And after this, if you try to reference this num, the compiler is going to yell at you and it's not going to compile. So let's see if we can run this guy. Yeah, that is cool. So switch again is a little different. In C, you cannot have dynamic stuff here. You cannot do type checking here. But in Go, you can have variable stuff here, and you don't have to add a break. But you can add an interesting guy called fall through. C to add a break. Well, Go has a variable that says fall through. So if I say I is equal to 1, no, let me put I is equal to 2 and run it. So of course it's gonna put print true and nothing else. Cool. But now if I go to say I is equal to 1, comment this fall through and run this, again it says 1. But if I write this fall through here, let's see what will happen. Oh yeah, it fell through, but there was no fall through here. That's why. Anyways, this was all like tough. Arrays, yeah, you can have arrays, but again, that's going to be weird syntax because you have to write the type at the end. You'll have to write a variable, what the size of the array, and then int. Now, if you look carefully, the reason why they do this is it makes parsing logic a little simpler because then it's simpler for you, for your parsers to figure out if you can, if the grammar is ambiguous or not. But again, I don't want to talk about those things. So yeah. So I mean, this is bonus stuff. I really don't have to cover all of this, but again, I just for the completeness. Probably done. We can have where we look into coding, but this was more like introduction. And is there a need for learning a new language? Anyways, slices, like slices is something that once like Ken Thompson was asked, what is the greatest thing in Go that you feel like is your achievement and you think that has simplified the code? So he says slices. Now slices is basically a growable array. Think of it as a vector, like vector or a list in Python. And there are some other things, there are intricacies to it, which I'm not going to. There's a very good blog post on the blog.golang.org about slices. Please take a look. I probably might give in a link for that because it will become too complicated if I start talking about it here. But again, think of them as growable arrays, but they have their own gotchas. Like if you have the backing array and then you finish off with that and you add one more element to it, it's going to, go to another backing array and copy that initial thing, do that kind of a dance. So let's see. So there is this interesting function, len, means length of this slice, and capacity of this slice. So the idea here is, what I want to do is I just want to run it and see what will happen. So it says I have made a slice with 3 capacity. I mean, it should have 3 elements in it. So I'm doing println employee. Okay, he's printing that slice and there's nothing. Then for the 0th slice, I'm doing A1 is B and C this. Then he says that, yeah, I did set. Where is the set? Yeah, set. Okay, set, get this, get this. Now, what I'm planning to do is I am going to call this again. No. I'm going to call this again. The capacity, notice it says capacity is equal to it, I add D to it, copy it here. Okay, just didn't let me copy. So let me write fmt println capacity after addition cap of s. Let us see. So now I only added 2 elements to it. Even if I added just 1 element, I had added to it, the capacity would have doubled. I have capacity here as, then and this is a gotcha, because a slice is just a view into an actual array. So if you are referencing something from here, the moment you add one more item to it, this original backing array is garbage cleaned, not really garbage cleaned, because that is copied over to a new place and then a new element is added to it. So this is something that we need to be very, very careful when we do slicing. So that's why we just don't have append slice and this. We always make it equal to s is equal to append s d. The reason we do this is, what if that slice was out of storage? So we had to allocate a new array for that and copy over the stuff. So this thing is going to take care of it, because append is always going to return the latest one. It may be the same old slice, it may be the new one. That's why you do s is equal to append. Again, not really interesting. What's a 2D slice? It basically is like you'd have to write a slice of ends, and it'll work similarly here, but you'd have to do a bunch of things with it. Again, 2D matrix. And yeah, this is mostly that I wanted to talk about. I know I took a lot of your time. So yeah, this is me. I am on Twitter and I mostly tweet about random stuff. EVPF is something that I really like these days, so I do tweet about that, and I do tweet about Rust and Golan. So please feel free to reach out. I will definitely try to answer you or try to respond back within reasonable amount of time.